Okay, so today I'm going to go over my ANCOVA assignment. So I guess we'll just jump right into it. First, I'm going to describe what an ANCOVA is and what it can do. This test can be thought of as an extension of the one-way ANOVA to incorporate a covariate variable. Usually this covariate is linearly related to the dependent variable, and its inclusion into the analysis can actually increase the ability to detect differences between groups of an independent variable. So we can use ANCOVA whenever we want to determine whether there are any statistically significant differences between the adjusted population means of 3 or more independent or unrelated groups. So if there's a variable that you want to control the effect for and see your main effects, then you can use ANCOVA. And it's most often used to analyze the results of two different types of study designs, the first being pre-post study designs, and the second being reducing the effect of an extraneous variable, which is the type that mine will be since I did not have an experimental design. You can reduce the error variance within groups, so more specifically explaining more of the unexplained variance, allowing for a more accurate assessment of the effects of the IV on the DV. And you can also remove bias of extraneous variables influencing the dependent variable. Other reasons that you might use ANCOVA include whenever you don't have random assignment. So what you need in terms of data and assumptions, a categorical variable, a predictor variable, a continuous dependent variable, a continuous covariate, homogeneity of regression slopes, homogeneity of variance, and I will actually go through all of those as I'm going through the analysis in R. So to present the rationale for running this ANCOVA, I want to see whether there are differences in performance on a selection measure across race. And I'm going to be controlling for cognitive ability because it's generally acknowledged that certain races score higher on IQ, which is actually a common criticism of how we measure IQ. And because cognitive ability has been demonstrated to be positively related to performance on various dimensions, including selection measures and general measures of job performance. So, of course, we don't want scores on our selection measures to significantly differ across race because that would indicate the presence of adverse impact could occur as a result of our selection measure scores. So a quick introduction to my data set. Sorry, I did not bring that up like I should have before I started the video. Here we go. Okay, so I actually made my data from scratch because I was having a lot of trouble. No, I don't want updates. Stop. Because I was having trouble finding data that I felt would be good to use with the question that I was trying to answer. So I made this data set by myself, and by doing so, I actually ended up making it really hard on myself to run this analysis, which we will see later on whenever I go through R. And so as you can see, we have a participant over here, so the just the number, the participant number, and then we have a race, and then I ended up coding for race over here so that I didn't have to set race as a factor within R. So assigning numbers to that. So white is 1, black is 2, Hispanic is 3, and Asian is 4. I coded IQ by looking up the average IQ scores of people from different races and kind of trying to stay within that within those parameters whenever I assigned IQ scores to individual participants. And backtracking a little bit for race, I actually looked up the percentages of each race, each of these races within the U.S. population, and then applied that to hold on. Hey, stop. Get out. Roscoe. Hey. Okay, sorry about that. My dogs, of course, decided to play at the worst time. Anyways, so I looked up the exact number or percentage of each of these races within the population and then applied that to my participant pool of 200 participants. And then for performance, I kind of just tried to keep it the same as IQ. So I made it to where like Asians scored higher and then Hispanics scored lower because I thought that would be like good for trying to find effects, but apparently it wasn't. So another thing that made this particularly difficult for me was the lack of experimental manipulation. So there's a quick intro to my data set. Now we're going to start going through the step-by-step explanation and execution of this test. So first, of course, I'm going to attach my data. And then I'm going to load all of this stuff into the library. We have PastText package, which you use for descriptives. ggplot2 is used for graphs. CAR is used for Levene's test and also to calculate type 3 sums of squares. Effects package is used to find the adjusted means. MultComp is used for post hoc tests. And for robust ANCOVA, we use WRS2. And so the first thing that I'm going to do to actually run this is set the categorical IV to as a factor. I'm only doing it here for purposes of the demonstration. As I said before, I've already coded for race within my data set, but if I hadn't, which I'm likely to encounter whenever I actually run these tests, then I would set the IV as a factor by attaching by specifying the variables within the data set, or the variable within the data set that I want to set as a factor. And then here we have the how many levels we have, and then here we have the actual labels that we're going to attach to each of those categories. Okay, so the first step is to explore the data. I'm using the by function in combination with the stat.desc function for descriptives. The IV is race, the covariate is cognitive ability, which is labeled as IQ in here, and the dependent variable is scores on a selection measure, and that was continuous on a scale of 1 to 10. My data is called ANCOVA data, and within that data we're looking at the 3 variables that I just referenced. So I use the $sign function to specify that I'm wanting to see those variables within my data set. So we run this.